Hello everyone, here is the solution for problem 1 in homework 10. So what is the Poisson process? It is defined by the following properties. The number of n is the points in the interval of length t equals t2 minus t1, and it's a Poisson random variable with parameter lambda t if pn t1 to t2 equals k is the equals to the exponential of negative lambda t times lambda t over with the power k over the factorial of k. So here is the probability distribution. So we assume that two intervals are non-overlapping. Then the random variables n are also independent. At a time moment t, there is no more than one Poisson point. The mean of the Poisson process is equal to lambda t, and the autocorrelation and the autocovariance are shown here. So second, what is the Poisson increment process? It is come from the Poisson process. Assume that xt is Poisson process, then yt is equal to the xt plus epsilon minus xt over epsilon. So it looks like the differentiate. The probability mass for the Poisson increment process is shown here. So it is equal to pyt equals n over epsilon, and the formula for the probability mass is exactly the formula of Poisson process here, and instead the t with epsilon. So the mean of the Poisson increment process equal to lambda, and the autocorrelation and autocovariance are shown here. So for what is the Poisson impulse process? It comes from the Poisson increment process. So look at this formula. If we let epsilon tends to 0, and then it is exactly the Poisson impulse process. The mean is lambda, and the autocorrelation and autocovariance are shown here. So what is the semi-random telegraph signal? So assume that xt is a Poisson process, and the number n of the points in the interval of length t is a Poisson random variable with parameter lambda t. If pn t1 t2 equals k equals to the exponential of negative lambda t times lambda t of the power k over the factorial of k. So we assume that xt equals to 1 if the number of k is even, and xt equals negative 1 when the number of k is odd. So here we could have the probability mass function here. So the mean of the semi-telegraph signal is exponential of negative 2 lambda t, and autocorrelation and autocovariance are shown here. So the random telegraph signal comes from the semi-random telegraph signal. We assume that xt is a semi-random paragraph, and let yt equals to a constant a times a variable a times xt, and the value of the variable are equals to 1 or negative 1 with equal probability. So here we could have the probability mass function for the random telegraph signal. So therefore the mean is obviously 0, and the autocorrelation and the autocovariance are shown here. So what is a random walk? Imagine that we toss a fair coin for n times, and we have number of k heads in the n tosses. So therefore xnt is equal to the number of heads times s minus n minus k. This is the number of the tail times s. So we could have the probability distribution here. So the mean of the random walk is equal to 0, and the autocorrelation and the autocovariance are shown here. So when the process come from the random walk, so assume that xt is a random walk, and wt is the limit of xt. So the probability distribution looks like the normal distribution with mean 0 and virus square root of alpha. So the mean of the winner process is 0, and the autocorrelation and the autocovariance are shown here.